So what do you expect to get when you add something like 0.1 plus 0.2? You expect something precise like 0.3, right? Well, in certain programming languages, that's not the case. This is something called floating point rounding or precision error. Now, this is a common issue with floating point numbers because of how they're programmed. They are not very precise. Now, a way around that is to use BigDecimal. BigDecimal is much more precise, but it comes with its own downside of being slower and much more complex to use than a regular double. So how do you get around this sort of error without losing much precision and being simple enough to not use BigDecimal? Well, a workaround is to round, and I like to round to the 10th decimal place, the actual 10th decimal place, to keep as much precision as possible. So is this enough to fix our rounding error? Well, it kind of is, yeah. You can see that the rounding error still occurs because we're using a double, but because we're rounding to the 10th decimal place, it won't matter. It will round it down to the precise number. But this comes with its own can of worms. What if we have a number that is way too big? That shouldn't be the answer, right? It should be something similar to this. Or, what if we have a number that's way too small? It'll round down to 0, when it should be something similar to this. So, we're getting more imprecision because of this. That's not a very good solution. So we need some kind of filter, right? To make sure if the number is too high or if the number is too low, we shouldn't be rounding because that'll cause more imprecision than we need. But if it's within a certain spot where floating point errors can occur and be very noticeable, then we should round to make it more accurate. I found that this is a good condition. The second part might not be needed, but I have it because the numbers are very high and very low. So now, if we have a calculation like 0.1 plus 0.2, the result will become rounded because it is within the range, and this will reduce the floating point error. And if we have a number that is way too high, it will still not become rounded and be more precise. Or if we have a number that is too low, again, it will not become rounded and it will remain more precise. If you need a lot more precision, then your best bet is to use BigDecimal. I'm sorry, I haven't found another solution around it. But if you need more accuracy, enough to not get these floating point errors or to reduce them, this is a good workaround. Rounding will still occur whether you do it or not. It will make more imprecisions whether you intend it to happen or not, but this is the symptom of rounding as a whole. You will lose less precision. Hey, subscribe if you like, hit the like button, and ring the